All right, beautiful people, let's go ahead and try number 9. So number 9, we're going to start off exactly how we started off earlier. Step number 1 is identify any GCFs. I'm going to wait just a little bit for you guys to write it out. I'm going to actually write it out as well with you. Here it is. Alrighty, GCF time. Step number 1 is always GCF. So I'm noticing an X, an X, an X, an X, and an X. So I'm going to pull out one X. I'm noticing a 25, a 165, so 5 can go in it. A 217 that's not does not contain a 5. An 87 that doesn't contain a 5, and a 10 that does. So there's no numerical GCF, it's just X. Step number 2 is to try factoring. Because if we can factor, I mean, we don't really want to use the rational root theorem. We don't want to deal with the silly snake. So once we remove the GCF, let's go ahead and rewrite it. I just realized I might run out of room, so I'm trying to write a little bit smaller. Barely made it. So I'm noticing I have 1, 2, ooh, do you see my hiccup? I have 1, 2, 3, 4, 5 terms, and because I have 5 terms, unfortunately, I cannot simplify using grouping, and that's the only method that we have. So we are going to continue by using the rational root theorem and the silly snake. Step number 3. Now, in this example, let me show it to you again. They did give us a root. I'm going to pretend that they didn't. Okay? I'm going to pretend that they didn't. So step number 3 is list all possible. Turn off the music here. So to list all possible roots, you are going to take the tail and place it all on top of the head. So we got 10 over 25. You're going to list out the factors of 10 and 25. So we got 1 times 10 is 10. 2 times 5 is 10. In the denominator, 1 times 25 is 25, and then 5 times 5 is 25, and that's it. Please do not leave your answer like this. Okay, this is improper. This is random numbers on top, random numbers on the bottom. So we want to actually write it out as fractions and simplify. So we got 1 over 1, 1 over 5, 1 over 25. Then we have 2 over 1, 2 over 5, and 2 over 25. Then we have 5 over 1, 5 over 5, 5 over 25. Then we have 10 over 1, 10 over 5, 10 over 25. Go back in and simplify the fractions, listing them out. So I get plus or minus 1. I'm going to deal with the whole numbers first. Plus or minus 2, plus or minus 5, plus or minus 10. Then I hit 1/5. I'm going to write it underneath because I'm running out of space. Then I get 2/5. Then I get 5 over 5, which is just 1, so that's gone. I get 10 divided by 5, which is 2. That's gone. We already have a 2. Then we have a 1/25. Then we have a 2/25. Then 5 and this is 1/5. Do we have a 1/5 already? Yes, we do. So we don't need that. And this is 5 to 22 fifths. And we do have a 2 fifths, excuse me. So that one's done. So when it's asking you to list all possible factors, the key word here is the possible, because you're going to see 3 different questions today. You're going to have one that's possible, you're going to have one that's all rational, and then you're going to have just all. So the possible means just don't check. This is your possibility. So these are your possibles. Okay, now that you have your possibles, step number 4. Step number 4 is to check which one root 0 makes the equation 0. Thank you. Now, it is your choice if you want to go back all the way back to the original equation. I actually don't recommend that. Just use the simplified. Once you remove that GCF, there's no reason for us to go back to all the way back to the original. So you're going to say 25 bubble to the 4th power plus 165 bubble to the 3rd power plus 217 bubble to the 3rd. Something happened. Second. Second power plus 87. Oh, I see my hiccup. X. And then 10. So my hiccup, if we go all the way back up here, I have 3 3's. So this should be 4, 3, 2, and then just 1. These should just go down. So in standard form, goes down. What you're going to do is you're going to input some of your solutions. So 1, 1, 1, 1, 1. Does that equal 0? Maybe. 2, 2, 2, 2, 2. Does that equal 0? Negative 1, negative 2. I'm going to jump, and because we originally are doing this question here, they give us that negative 2 fifths does work. So I'm just going to cheat a little bit to save time, and I'm going to say, oh look, negative 2 fifths works. So that gives us a 0. Wow, shocker. Bless you. Okay, so then we have step number 5 is we're going to use synthetic. Upside down. Then we have 25, 165, 217, 87, and 10. And then they give us the root was negative 2 fifths. I also want to do this type of example today to show you how to deal with fractions. Because fractions tend to be scary. And they're not scary. That's okay. Bring down the 25 just like we did originally. Again, if you don't have a calculator, please go get a calculator. You need to practice using your calculator. Otherwise, on Monday, you're going to be asking me, what do I type in? And I'm going to say, I'm sorry, I can't tell you. You got to practice. So everyone should have a calculator in your hand right now. Okay, I'm going to do a little bit of a thinking bubble here just to show you what I'm talking about. Whenever you are multiplying by a fraction, so here's your negative 2 fifths, here's your 25. You're actually going to multiply and then divide. So it's like saying negative 2 times 25 divided by 5. Because that 5 is underneath in the denominator, it's actually division. So negative 2 fifths is negative 2 divided by 5. So what you're doing on your calculator is negative 2 times 25 divided by 5. And that is what you're going to write in here. So this is negative 10. So we multiply and then we add on the inside. So now we got 165 plus a negative 10. And I get 155. We're going to do that again. So we're going to multiply by 2, negative. So 155 times negative 2. Then we're going to divide by 5. That gives me a negative 62. So again, we're going to add 217 plus a negative 62. That gets 155 again. I don't have to do anything because we already know that that's going to be negative 62. 87 plus a negative 62, that is 25. Hopefully that gives me 10. 25 times 2 is 50 divided by 5. That does give me 10. I kind of hesitated there. Had a little bit of anxiety, to be honest. I'm like, oh, is it going to work? It has to work, right? It has no choice. If this is your 0 in step 4, then this has to be a remainder of 0. If it isn't somewhere, there is a mistake, either in 4 or in 5. Okay, now write it out. So here's your R, 0, 1, 2, 3, 25x cubed plus 155x squared plus 155x plus 25. This is where yesterday I need to kind of be a little bit more detailed. This right here that we got from our first synthetic division, when we had a fraction as our root, this is considered unsimplified. Notice we have a 25, 155, 155, and 25. We can remove something. What can we remove? A 5. Let's go ahead and remove a 5. So we got 5x cubed. 155 divided by 5 is 31. X squared plus 31x plus 5. This right here is your now simplified. And that is what we are going to continue with. I'm going to try and see if I can grab another color here. Yes, I can. So this right here is what is simplified and we continue with. This will always happen when you have a fraction. If you did not do synthetic division and you did long division instead, you would never see this 25. With long division, this would happen, this 5x squared. You would never see this 25, 155. But because we're using long synthetic, do you hear what I said? Because we're using synthetic, we have a fraction, then we have to simplify. All right, let's continue. I hope we're done. Can we factor? Because I see 5 and 31. My gut is telling me we won't be able to factor, unfortunately. Can we factor or no? We got 5x cubed plus 31x squared plus 31x plus 5. Because this one here, 31 and 5, they don't have anything in common. I do see an x, so if I pull out an x, but then the x is going to be on 5 and not on 31. So that means we cannot factor. Shucks. If we can factor, then it saves us a lot of time. So then we're going to, step number 6, we're going to try again. We're going to not make, we're going to find more roots. So we get 5 something cubed plus 31 something squared plus 31 something plus 5. So help me out. I'm going to try what were our roots. We got 1, 2, 5, and 10. Someone try positive 1, someone try negative 1. Someone try 2, someone try negative 2. Someone try 5, someone try negative 5. So we can kind of work as a team. I'm going to randomly try a negative 2. So I'm going to type that in. Someone else try positive 1, negative 1, and a positive 2. I'm working on negative 2. And if you get a 0, shout Eureka. Aw, I don't get to shout Eureka. Which one? Negative 5 works. Great, fantastic. You didn't shout Eureka though. Negative 5. So since negative 5 works, we're going to now do step 7. Oh, I switched colors. That's okay. And we are going to use synthetic again. Upside down. We got 5, 31, 31, and 5. And we got negative 5 out. And again, this is our way of checking as well. If we don't get a remainder of 0, something wrong happened. So we got 5. 5 times 5 is 25 with a negative. 31 minus 25, technically plus a negative. Again, we're always adding. We get 6. Then we get negative 30, and we get 1. Then we get negative 5, and we get 0. Yay, it worked. Happy dance. All right, now that we're here, we're going to rewrite it. Oops. R0, 1, 2 squared 6x plus 1. Notice that because we did not have a root that is a fraction, this cannot be simplified. 5, 6, and 1 can't be simplified. So the simplification only occurs when you have a fraction. No fraction, you're fine. And then we're going to step 8, try to factor. Maybe we can, maybe we can't. So 5x squared plus 6x plus 1. We have a trinomial with a leading coefficient that's not 1. So let's try rainbow method. So you have x squared plus 6x plus 5. Can we factor? Oh, 5 and 1. Happy dance. 5, 1. Please do not stop here. Don't do it. This is not your answer. This is not your factors. This is some randomness. You multiplied by 5. So now you have to divide by that 5. So that means we have x plus 1. And since we can't simplify it, we go 5x plus 1. These are now your factors. Not your answer, just part of your factors. Okay. How does the answer look? Like, how do we actually write the answer? When you're looking at the answer, I want you to follow this kind of, I mean, it doesn't have to look exact, but just this mindset. When you have a root, our first root, let's go all the way back, that was a negative 2/5. That root belongs to a factor. And that factor is opposite of what you see. So if we see a negative 2/5, it will be a positive 2/5. However, we do have a fraction, so just like we do when we're traditionally factoring, we got to move that to the front. So we got 5x plus 2. Then we found another root. That other root was a negative 5. That negative 5 belongs to a factor. And that is x plus 5 because we do opposite of what we see. Then we didn't find any roots because we were able to factor and find our last two factors of x plus 1 and 5x plus 1. These were found by factoring. So then, the main important event, did we have a GCF at the very beginning? Not in the middle. Never in the middle. In the beginning. Yes. We had a GCF of x. So we are now going to write out our whole answer. GCF always is first. The remaining factors, the order doesn't matter. So we got 1, 2, 3, and 4 factors that we need to write out. The order doesn't matter. I'm going to go top and to bottom. And these are your factors for what we originally started. This is your answer.